In this lecture, we are going to discuss about necessary condition for a function to be analytic. If a function fz equal to u xy plus iv xy is differentiable at z equal to xy, x plus iy, then all the four partial derivative ux equal to del u del x, that is differentiation of u with respect to x treating y as constant, del uy, that is differentiation of u with respect to y treating x as constant, bx, that is differentiation of v with respect to x treating y as constant, by differentiation of v treating x as constant with respect differentiation of v with respect to y treating x as constant are exist and satisfy the condition del u del x del v del y minus del u del x del v del u del y del v del x. These conditions are known as Cauchy-Reiman equation. In short, CR equation. That means if a function is analytic, then all the four partial derivative exist and it satisfies CR equation. Now proof. We are given fz is equal to u xy plus iv xy, z is equal to x plus iy, delta z is equal to delta x plus I delta y. Put this equation 1 since the function fz is differentiable, at z, therefore the limit f del z equal to limit del z tends to 0, delta f by delta z given by limit delta z equal to 0, fz plus delta z minus f of z by delta z exists uniquely as del z tends to 0 along any path. As the function is differentiable, this limit exists independent of the path. Next, put this equation 2 using 1 this definition of function. In 2 we have here z equal to u xy, So when it is z plus delta z, it will be u x plus delta x, y plus delta y, b x plus delta x, y, the y plus delta y. So put this value. Now using 1, using 1, 2 becomes, using 1, 2 becomes fx z is equal to limit delta z tends to 0, u x plus delta x, y plus delta y plus I b x plus delta x, y plus delta y, bracket. Then minus u x y plus I b x y. Put the value of fz, divided by square bracket close delta z. What is delta z? Delta z is now my delta x plus I delta y. Okay. So rearrange this term. Write u with u. This will be equal to limit delta z tends to 0, u x plus delta x, y plus delta y minus u x comma y. Then from this term take I common, then write with it, that is I within bracket p x plus delta x, y plus delta y minus bx comma y. Put the value x in the denominator, it is delta x plus I delta y. Put this equation 3. Since derivative of the function x is independent of the path, so we will take del z. Taking del z tends to 0 along real axis. In next step, taking del z tends to 0 along real axis, then delta y is my delta y is equal to 0. Delta y is equal to 0. Delta y equal to 0. If I put delta y equal to 0, this will be 0, this will be 0, this will be 0. So that in the next step, I have the, in place of delta z, I have delta x tends to 0. So next step will be limit delta x tends to 0, and here u x plus delta x, y, delta y is 0 minus u x y. Okay, bracket close. Then plus I within bracket b x plus delta x, y minus b x comma y divided by, this is minus, divided by delta x. Now write separately. This is equal to limit delta x tends to 0. Using the properties of limit, I can write this as u x plus delta x comma y minus u x y divided by delta x within bracket, this one, put the brackets, then plus I limit delta x tends to 0, put bracket, then write bx plus delta x y minus bxy divided by delta x, bracket close. This is the here increment is given to x variable, that means it is a partial derivative of u with respect to x. So this is del q by del x plus I. Then again increment is given to x variable, so this is del u by del y. Put this equation 4 as f(x) axis. Since fz is differentiable, therefore del u del x and del u del y exist. Okay, again taking del z tends to 0, along y-axis, we have del x equal to 0. Therefore equation 3 becomes this equation 3. This here putting del x equal to 0. At this time this equal to 0, this equal to 0, this equal to 0. And regarding delta z equal to delta x plus I delta y, this portion is equal to 0. So as delta z tends to 0, I delta y tends to 0, that means I is my constant number root over minus 1. This implies delta y tends to 0. So here as we take therefore equation 3 becomes f(z) equal to limit del y tends to 0, then here u x y plus delta y minus q x y divided by here I delta y, put bracket. So before writing this we have to write the numerator first, that is plus I b x within bracket bx y plus delta y minus b x comma y, bracket close, put the square bracket, then put I delta y, then write separately u and b terms. We will get in the next step. We will get limit del y tends to 0, then u x y plus delta y minus u x y divided by I delta y, then plus b x y plus delta y minus b x y I delta y. So bracket close. Now using the properties of limit we can write this is 1 by I limit del y tends to 0 within bracket, this is u x y plus delta y minus u x y divided by delta y. there will be one I here, one I here. This I and this I will be cancelled out. This I and this I will be cancelled out. This I will be cancelled out. This is a square bracket plus limit delta y tends to 0 v x y plus delta y minus bx y divided by delta y. Increment is given to y variable, that means this is the differentiation. 1 by I is minus I, and increment is given to y variable, so it is a partial differentiation of u with respect to y, plus this is partial differentiation of b with respect to y. This is the, in the left hand side it is fx. As function is differentiable, so this partial differentiation exists. This is my 6, this is 4 5, not 6, this is 5, this is my 5, equation number 5. This is equation number 5. As fx exists, so this quantity are equal, that is equation right hand side of equation 4 is equal to right hand side of equation 5. As the function is differentiable, as fz is unique, we have what is the right hand side of 4, that is del u del x plus I, del v, this is del v, not del u, del v, del u del x plus I, del u del, this is not quite that, this is x. Correct this mistake, remaining will be all that. Now, that is increment is given to x variable, so this is del v by del x. So right hand side of the equation is del u by del x plus I del v by del x. So write this. We have del u by del x plus I del v by del x is equal to right hand side of the equation 5, that is minus del u by del y plus minus I, there will be one I, minus I, then this is del v by del y, del v by del y, del v by del y. So equating real and imaginary part, we get here real part is this one, real part is this one, that is del u by del x is equal to del v by del y, and imaginary part is with this one, that is del v by del x is equal to minus del u by del y. These two are known as Cauchy-Reiman equation, in short CR equation. With that, I would like to conclude. Remaining will be in the next lecture.